by taking an X-ray, not sufficient. They go for a CT scan. From the CT scan, they infer that some artificial implant or external implant needs to be placed inside the bone. Okay, so they have identified using a CT scan or an X-ray. So this is pre-operative imaging, which is obtained from an X-ray or CT. But during my surgery, for example, I'm placing this metal, I'm placing this plate into the patient, for example, say, if such is the case, I will not be having a facility to take this X-ray machine there, and I cannot keep exposing the patient to X-ray, and I have to watch the film or CR or DR, whatever it is. You have computerized radiography nowadays, where you take and put the cassette in a reader, you will be getting the image in your system, or DR system, you will be getting time to time images. You put a click, within 2 or 3 seconds, you will be getting the image in your laptop. Yes, that is all possible. But taking a laptop and a cassette to the operation theater may not be advisable, because how will you sterilize that? How will it be autoclaved? These are shortcomings of a X-ray radiography, especially digital radiography. So for these purposes, we can go with CM during surgery. So during surgery, I say that I'm going to implant in this particular place. How do I know that I'm implanting only there? So I can take a video kind of frames, continuous frames I can also take, and I can review all these images to see the positioning. So during surgery, I take a C-arm to ensure that the fixation is being done in the proper anatomical site. And after the surgery or in between the surgery, once the fixation is over, you take an image again, and you will have to re-verify whether it is properly placed, whether the anatomical structures are all fine, physiologically will it be okay. All these things has to be verified after fixation. So you take a CM image after final fixation. Suppose you will have to revise it, it's not proper, you have to redo, you have to refix, take and modify something. If such is the case, you go for a refixation, and then you take the image if required. Once after the everything is over, you put the suture, close the surgery will be over, and the patient will be coming out of the surgery to ICU or ward or whatever, after which you will have to retake an X-ray or CM to ensure it is all proper. Okay, so a C-arm is a real-time X-ray. You can understand that way. Instead of taking an X-ray, watching the film or viewing that in a system on a laptop, you can simultaneously see in your monitor, and you can also perform all the image processing operations in this image which is obtained in your monitor. So initially, first CM was developed or was implemented into practice in the year 1955. Just imagine, from the year 1955, what are the evolutions that it would have suffered all these 50 years. So the mechanism basically here of the working of a CRMS, I'm not going in depth with the instrumentation, because most of us will be knowing when we talk about imaging, X-ray is a very important source or important modality of imaging, and most of us here would be knowing how X-ray imaging works, how a normal X-ray works with soft and hard X-rays, the bones, how are they being captured, a thick tissue, how is it being captured. I'm sure you will be knowing that. So having this in my idea, I am proceeding this further. A CM comprises of an X-ray source generator and an image intensifier or a flat panel detector. Even if we use flat panel, we are used to calling it as II. We commonly tell as II, which is image intensifier. It is very common term which we use. Any technician also uses the same term. So as I said, you have a source at one side and detector at one side. The source here is X-ray source or generator. The detector which we use here is image intensifier. The C-shaped connecting element allows the movement horizontally, vertically around the swivel. We will be seeing the degrees of freedom, how far you can rotate or what are the angles with which you can take. By seeing that, you will really be able to appreciate the innovation of a CM. We will be seeing that also later. So you see is a connecting element which can be used to move these X-ray source and detector parallelly. It will be oppositely posed, so that whenever you move the source, you don't have to position the detector. Automatically, the detector will also come to its own position. There is a greatest advantage. That's why we use this in theater, because when we use for radiography, you have to position the cassette every time, which is practically not possible. You cannot lift the patient, position the cassette downward. That cannot be done so easily, right? So that is the greatest advantage of a CM, is that your detector moves along with the source, just like a CT. As your source moves, the detector also moves automatically. The generator here emits X-rays to penetrate the patient body. The detector converts this X-rays into visible image. How? We will be seeing it in detail for image intensifier and flat panel detectors in the upcoming slides, so that the doctor can then identify and check the anatomical details on the image, such as blood vessel, bone, kidney, everything, whatever it is. You can just simply start your analysis or monitoring, diagnosis using your C arm. So this is the basic introduction of the mechanism. So this is how a C arm will be. So whenever we use an image intensifier, that is going to convert your analog to digital, and then it is being displayed in a monitor. A monitor is basically analog monitor which are being used. These are now not in practice actually, but still the people who had bought it in earlier days are still using the same C arm with image intensifiers. Nowadays the technology has greatly improvised that we are using only flat panel detectors most of the times instead of a CRT monitor. So X-ray source, patient comes to the image intensifier, and just above this image intensifier you'll be having a camera unit. By before end of the session, we will be able to open a machine of using this image intensifier. There we can see what is what in detail, which will be handled by Mr. Zahir Hussain sir, our CEO. And analog to digital converter, there you do the image processing and you store this image. That is the greatest advantage. Once the surgery is over, you can write in a CD or you can do it in a pen drive and you can give to the patient to see how the implant has changed their anatomical structure. Initially, how it was, how the procedure was going, how the implant was done, and how it has changed the structure right now. Everything could be viewed as a video by playing these frames in a particular sequence using a monitor. So when we come to flat panel detector, it's a digitized flat panel detector, just like any other digital X-ray system. So it will be detecting the X-rays and it is given to image processing and storage and displayed using a LCD monitor. So coming to evolution, what exactly is this C-arm, or who is the parent of the C-arm, or what is the after C-arm evolution, what has happened after C-arm, everything can be understood here. So the first emerged was a basic fixed radiography, which is a normal analog radiography, where it's a conventional radiography where we use a film, go to the dark room, watch the film, and then you can get the image. This is a conventional radiography. Then came computerized radiography, where the cassette was readable. You did not have to watch the cassette. Instead, you can read the cassette in the system and you can reuse the same cassette. You don't have to change the film every time. So that was your computerized radiography. I suppose you will be knowing this. And with this idea, I proceed further with digital radiography. The difference between CR and DR is that in CR, you have to take the cassette, put into the cassette reader, and then the image will be obtained in the system. But in DR, you can place the cassette beneath the patient, expose, and immediately within few seconds, you'll be getting the image in your system. So it is very spontaneous. So most commonly used in veterinary applications also, because it will be very hard for you to position the animals. So once you position, you can take multiple clicks also when we go with the DR. And whenever we are using these kind of radiological equipments, please be informed that we will have to get a certification from AERB. Atomic Emission Regulatory Board will have to certify that your equipment is okay, for which you will have to submit a certificate to them called as Quality Assurance Certificate. These are additional details which we should be knowing. So when I say it is quality assurance certificate, you will be checking the emission leakage everywhere. When you use a C-arm, just nearby that X-ray tank, at a particular distance from that X-ray tank. So all these things is being given by AER. We have a tolerable limit. If your machine is not within the tolerable limit, then you will not be certified and you're not supposed to use that machine. Okay. So to ensure this, you have something called as quality assurance certification, which is being done by AERB approved boards, AERB approved companies. They will be doing and they will be certifying you. With this certificate, you can get an approval from AERB. It's just an online portal, free of cost only. You can just apply and you can get it certified, which is valid for 5 years. After 5 years, you have to redo the same procedure to ensure that radiological emissions are being in control. This is a very important thing which we will be discussing even in future slides. Radiological emission is greatly controlled by the board, central government board, AERB. So then it is C-arm, which is an X-ray only, but portable X-ray, where the detector and the source both will move together. Here, if you can see, this is the X-ray tank, X-ray source, and this is the detector or image intensifier. Even an image intensifier, there are various sizes. So then it is CT scan, which is like an O arm, where the source and detector will be moving throughout the O actually to get a cross-sectional view, and it can be reconstructed. This is a cath lab. I'm not sure if you will be knowing what a cath lab is. Cath lab is referred to as catheterization laboratory, which is commonly used in cardiology. This is a C-arm. If you can see, cath lab is also a C-arm. See this. This is the C-arm. Okay. So cath lab is also a C-arm, but it can move through the theater. It can be moved anywhere. When I say it is a C-arm, I can slide the C. Okay. But I cannot move it very easily. You have to put this portable, you have wheel, you have to change it somewhere like that. But here it is remote operated, where you can move it like anything. A cath lab is a hanging C-arm, ceiling hanging C-arm kind of thing. I think you can visualize what it is. So it is a ceiling hanging C-arm which can move around throughout. Up to my knowledge, cath lab is the very higher end equipment I know in the medical field. CT, MRI, it's nothing in front of a cath lab. Cath lab is a very higher end equipment which can be installed and which can be seen in only cardiological specialty hospitals where they post very high critical cases also. So cath lab is also a C-arm, which is ceiling hanged C-arm, which can move around the railing which is put in the ceiling. So as I said, there are two types of detectors. One is analog image intensifiers and another one is digital flat panel detectors. So when I say it is analog image intensifiers, how does it work? The X-ray will strike a fluorescent surface after being attenuated by the different degrees through the patient body. The X-ray passes through the patient body and it will hit the fluorescent surface, and that fluorescent surface will glow based on the input radiation strength. If the X-ray is strong, then the brightness will be greater. So the phosphorus screen which we use will be fluoring or glowing based on the input X-ray. And just behind that, you will be having an image or a camera which can capture this phosphor image. That's all. Over. And that image is being processed with your digital imaging processing system, and then it is stored in a memory and passed on to the monitor. Only that much. I think it should be very clear. So I'm not, you will be knowing basically about these camera and image processing systems, I suppose. So due to the curved surface of the tube, the accuracy of the image diminishes over the edges. So for this overcoming, we came with something called as digital flat panel detector to avoid these kind of edge or distortion at the edges, loss of information at the edges. So these are modern flat panel technologies, just like a digital radiography. We have flat panel technology here also, except that it is directly connected to the monitor. It is not movable. You cannot remove the detector and you cannot move the detector. So the intensity of the incoming X-rays is converted into a digital value by these photo detectors, these radio detectors. And this is then given to your digital processing system. So first time this digital system was innovated in the year or implemented in the year 2006. So if you can see 1955 to 2006, it took almost 50 years for us to digitize or to improvise or to overcome these distortions or erosions which were occurring in the analog mode of technology. So coming to the positioning of C-arm, there are various things which needs to be taken into consideration when we use a C-arm or any other radiological device. The thing is, the patient as well as the technician must be exposed to very less radiation. That is the basic idea, because radiation has its own harmful effects, as you will be knowing. So to overcome this, we will have to ensure that both the patient as well as the technician are being exposed to minimum radiations. So the first thing is you will have to position the C arm such that the radiation is minimized both to the patient as well as to the user. So for that, we have to ensure that the patient should be closer to II instead of X-ray. Number one. And number two is that always your X-ray tube will go down. Image intensifier will come up. Why? Because you can see in this image, it will be very clear. If the X-ray tube is down, you can see these are the X-rays. These shaded regions are the X-rays which are penetrating within the lower region of the table. Here, if you are keeping the X-ray tube upper side, you can see that the exposure to the patient is also high. The exposure to the technician is also high. So it is always advisable to use X-ray below the table. I suppose you must be getting a doubt here. How, see, I'm using a normal OT table, which is a rigid surface throughout. I am using an X-ray source below the table. Will this table also appear in my X-ray image? So this will be the greatest question. So no, this table will not appear in the X-ray image. Why? Because you cannot take an X-ray with a normal OT table. To take an X-ray, you need CM compatible OT table where all these mattress just below the mattress will be having that base, no, where the patient lies down. That is made of a special acrylic which will allow X-rays, which will not scatter or which will not reflect X-rays. It will simply pass the X-rays through it. So that is called a C-arm compatible table, which is a mandatory tool to be used along with C-arm. Another way to reduce the exposure to the patient. Suppose my area of interest is less. I am focused with a particular area of interest and I need a high quality image. If such is the case, I have something called as a collimator, which is also used in any other radiological device, even in DR or X-ray. We use this something called as collimator, which is used to narrow down, which is used to focus the X-ray, which we expose to the patient. So when I have an open beam, you can see that the scattering is also high, so the image degradation will also be greater. When it is collimated, there are two advantages here. One, the image quality is also improvised. The patient is also given with a lesser radiation. In turn, the technician will also be given with a lesser radiation. This is the idea of using a collimator. How can we move the C arm? I was telling, no, you can move the C any way as you wish. How can it be moved? If you can see here, one thing is this way. I think you can understand. You can swivel, na? You can rotate this like a CT. Just imagine if it is a CT, how will it rotate this way, right? So up to this degree, you can just rotate this way. This is swivel. Vertical height, increase decrease the height based on the patient and table position. Horizontal, front and back motion, can front and back motion. And rotation is this way. Try to understand, not like CT. Instead it comes through this, slide this. For example, the intensifier comes here in this area and the source will be opposite to this area like this. So up to 190 degrees you can rotate this way. So that is rotation. So these are the 4 degrees of freedom which is given in a C arm basically. So with which you can cover almost all the angles with which you can cover a CT. The CT edukumbodhu you can cover all the angles. Yeah, same way you can cover all the angles when you use a C arm based on the positioning, for which you will be needing an expertise. Not everyone can position this so easily, because to view a particular tissue in a particular angle, you need to position it properly. That is very, very important, which can be done by any technician. So params of concern, you will have to reduce the amount of exposure of exposure of the radiation, adjust the distance so that both the patient as well as the technician are getting lesser radiations. Ideally, the patient should be placed 12 to 15 inches away from the source. So we are placing the patient as close as possible to the image intensifier, and only whoever is authorized should be allowed inside the room. And when the procedure is performed, the technician has to be near the image intensifier, not near the source. Suppose you are using parallelly, for example, The example which we saw was the X-ray tube was below the table. Now, if both are parallel, for example, both are upwards, you are putting the C horizontally, then you will have to be at the side of image intensifier and you will have to be away to the patient. And remember, the whole operation theater where we use CM should be lead shielded to avoid exposure outside the theater. And we have our own accessories to protect ourselves, like lead aprons, thyroid shield, and gonad shield to protect, to avoid the exposure of X-ray. And we will be having radiation badges and dosimeters. The radiation badges should be worn, and we have to ensure that we are not exposed to more than 20 sieverts per year actually. So if such is the case, you are getting exposed to that, you will have to go for a vacation for a few while and then come back, because radiation has its own harmful effects and it is also carcinogenic. So I said that the C-arm image intensifier is of various diameters. So based on the diameters, again the patient dosage is also controlled. Higher the diameter, greater is the field of view. High resolution you will be able to obtain from that. The intensifier diameter is greater, lesser is the patient dose, and that is being shown in this presentation. So as far as the instrumentation part of it is concerned, I'm not going to focus much in the instrumentation part of it because we'll be seeing in the practical demo. So with this, I conclude my theory. Any doubts you can please ask now. Any doubts you have in the theory? If not, I'm proceeding with my video presentation.
Yes, sir. You can proceed with the video, sir.
I'm just opening it. Once the video start, I want any one of you to just let me know whether the audio is okay. That's it. Is it audible?
Yes, sir. Yes, sir. It is audible, sir.
Just like any X-ray, we will be setting the KV and MA. So we proceed with the next session of the practical, which will be handled by Mr. M. Jahir Hussain, proprietor CEO of BioVision Medical System, who is an
My
expert.
name is Rebecca Hammond. I'm a clinical imaging specialist with GEMC.
Who is an expert technical professional with over 30 years of experience in healthcare sector. He served as Director Technical for Sigma Meditech India Private Limited, Chennai, and handled various medical equipments and catered to the needs of all specialties of medicine. He is also heading the technical operations at AMS Solutions INC Chennai, which deals with a wide range of medical equipments in general segment, anesthesia, and cardiothoracic in particular. His core competence is high level of technical skills, strategic planning, and new business development, product identifications with all India dealer network operations and management. Mr. Jahir Hussain has gained unique identification in the medical industry of Indian origin. He commands high regard and respect for his professional ethics and highest level of technical knowledge, dedication, and devotion. The greatest strength is the commitment in offering 24/7 service and customer support to all the healthcare professionals across India. So further to this, I'm giving his presentation. He's not live actually, but I'm giving his presentation. Further to this, if you have any queries there also, you can please ask me. I'm proceeding with the presentation now.
Good afternoon, everyone. Today we are going to take about the SIAM classes. First thing, what is SIAM? Why it names SIAM? Because it is the shape is a C type of shape. That's the reason it is called a SIAM. Actually, this is basically it is again the X-ray family. What is the difference between X-ray and SIAM means? In X-ray, it will be fixed in one place. You can take the object or anatomy. In between that, you can take the images. Images means it will come through the film. Or nowadays, there are a lot of new technologies like computer radiography, CR system, and DR system. So many new techniques has come. Okay, so in the earlier the SIAM was invented in 1955. It is they started with the ortho. Suppose you want to do any cases in the theater, like bone, you want to implant anything, you want to keep some screws, or you want to put a plate and all that. So after fixing that in the surgery, during surgery, after fixed this type of ortho implants, they want to confirm with the X-ray whether it is fitted properly or not. Not only ortho, the SIAM is using in different. You can use it for in urology, you can use it in cardiology. Of course, cardiology means again the same SIAM. In cath lab, you heard about the cath lab. Cath lab also similar setup, but it is very less than kV. In that cath lab, they will use more kV and some other different type of images they will take it. And also it got some memory unit. It stored the image. Suppose if they are taking during the surgery, they will take a shoot. First they will take a picture and they will store in the memory unit. Okay. Before that, I will inform you. There are two parts in this SIAM. One is C-arm. This is normally kept in the theaters. OT, they will use this SIAM, and this is a memory unit. So whatever you are taking the image, that will be stored in the memory. So later on, after the surgery, you can recall the memory. You can go through that. So what they fixed or not, like that. Okay. Siam again is after the Siam. Suppose in X-ray, in this part there are two parts. One is the X-ray. This is the X-ray tank. This one is the image intensifier. See, now this is a old type of IA. So current now old type means this and all that like CRT. You heard, I mean, the old TV and all that, you know. Then they use the cathode ray tube. Like that they use this. So once X-ray is generated by tube, so it is passing through the object. Object means either anatomy. So again it will be captured by the IA. Again it is converted into the image. Understood? So this is IA. Anyway, we will open and see that IA, how it is working and all that. I will tell you later. Before that, just I am giving you the idea what is what. Okay, again, memory. Memory actually in the memory unit there are two monitor will be there. One monitor is taking the live image. Other monitor you can store the previous one. So that the doctor can see that what is the difference between the object. Okay, and of course you can. This is actually memory unit. In that memory unit you can store up to 100 images. Suppose you want to store more images, then you can put some computer and a graphing card, so you can store it also. And this key can operate through the console. In that console, here you can see that kV and MA, how much kV you need and how much MA you need. Okay, and so up and down. Suppose they have the inside the machine, they have the motor. So the motor will move the up and downs of the C, and you can also rotate 180 degrees. 180 degrees you can move it. Okay. So here we are setting about 58 kV. So you want to reduce this kV also depends upon the object. Suppose I'm going to take my hand, so I can keep about 40 to 50. See, once I set the kV, so this is actually foot switch. Either you can operate through this foot switch, or you can have the exposure switch will be available in the system also. So normally this foot switch will be kept in the near the surgeon. So once you want to see the image, so in between that they will put a object means patient will be there in between that. Okay, and in between the patient will be there, and the table also sometimes they will use a special type of tables. So all the OT table cannot use for the CM. So it got the CM compatible table is available in the market. You can use that one. Okay. Just now I kept my hand up in between that X-ray and IA. See the monitor. Now actually I kept 40 kVA, but my image is not clear, so I need a more kVA to expose. So I'm increasing this around 50 above. Now you see the quality. See, so I can see my hand. These are the bones. What are the bones available? So like that you can expose like a hand, or you can take some arm. Spine. Okay, this is spine of patient. So here you can see all the L2, L3 like that. So that and all that doctor will know that. Just I'm showing how to take the spine and how to take the hand and all the imaging the something. Okay. So after that, after the expose, either you want to, you can adjust like a post processing. Here actually mic. Just I showed you what is CM, how to expose, how to keep the KV and MA, and how long I can shoot. Everything just I explained to you. Anyway, what we'll do, we'll open the CM and we'll explain some more techniques. Okay. In the market, there are a lot of companies, competitors are in the market. Like see major companies like Philips, GE, Siemens, they are all pioneer. Okay, and of course they are all importing from like the US and UK, different countries. And in India also, India we are making concept. They are also making some local companies are available like Challenges, RMS. So what they will do, they will assemble all the X-ray tube and other part. They will import only the tube. Tube is from like a Toshiba and some Philips. They have the different type of IAs are available in the market. Okay. So now we are opening one CM. We are opening one CM. First they are removing this IA part, image intensifier. So you can see that actually you can see a lot of so many components inside the tube. Tube will be, this is a tube. Actually tube, this is a tube. Tube is like so inside the tube will be there. This is a camera, okay, and you can see some this is a power supply, high voltage power supply. So this will generate more than 25 kV. So this only absorb the once the X-ray is emitting, it will hit the IA tube. So the IA tube inside the phosphorus will be take up. It will come out from the tube. So that will be absorbed by the high kVA voltages. So normally it will be about 18 to 25 kVA voltage should be inside. So before opening that, you make sure all the safety features. You have to remove the power cord and other things. Then only you have to open it. This is a camera. This camera can also remove from the. See here the tube. Inside the tube will be there. So the image will come this lens. This lens will be connected with the camera. So camera will absorb the image, and after that it will process all the digital process and everything. Then the signal will be transmitted through the video cable to the console. Okay. This is a camera. See here you can see that this is high voltage power supply. This is all circuit, electronic circuit, which will deliver the voltage. Now we will open this X-ray section. See, this is the X-ray generator. Okay, from this is again it's called a collimeter. Suppose you want to take the image. It's called a region of interest. So a particular point you want to focus and you take it. You need the collimeter. So this collimeter also you can adjust through the keyboard. How much shape you want like that. So if you open this, then you can see the tube. It's a tube. So the tube is filled up with the oil. Okay, inside the tube there are oil will be there. Remove the IA tube. These are our radiography, radio imaging system, and also it should be this license will be provided by the AERB. AERB means Atomic Energy Regulation of Code. So they have to issue us license. Okay, because in there they will have some norms how to, suppose we are going to keep this CM inside the theater, or you are going to keep the X-ray in a different place. So they have some norms. What is the norms? You have the security, safety and security. Okay, so they will construct the wall thickness should be like this. After the wall, you have to put some lead glass and lead tubings. Okay, that and all that be decided by the ARB. So once if you apply the ARB, once you get the equipment, you have to apply for the ARB to the hospital. So ARB will inspect and they will certify whether your CM or your X-ray system all are safe conditions. So you can, because it should not harm to other patients. Okay. So here the tube, it's like a glass tube. So here only the X-ray will hit, and all the phosphorus inside it is coated with the phosphorus, plain phosphorus. Okay. Now we'll first I'll remove the camera. So only one connector, and this is video cable. So now I separated the camera. Okay. So now I am removing some cable from the C. Okay, isolated. So now the tube is isolated from the C. So while taking the IA, because it is like a counterbalancing, you see, if I am removing that, before that I have to put a lock. This is the lock. I close it. Now it will. So before opening the IA, you have to take a extra care, and you have to follow the company rules and regulations. How to open, what are the safety features you should take, everything. You have to read the manual before opening the IA. See here, you can see that this is a power supply. I told this will generate the, you are applying the 48 volts, then it's inside the high voltage converter will be there, that will increase the voltage like a 25 kV. This will go to the anode of the IA mentioned in this way. Okay, and also the board is also very costly, and you can remove the power supply, but you cannot repair it, because this power supply was completely isolated with some kind of special material, so that there is no, because it's a high voltage, no, we should not arc to other boards or to the tube or something. Okay, so that's the reason the power supply was kept inside the tube. Okay, so here only after the 230 volt will be converted into multiple voltage, like 5 volt, 12 volt, 24 volts, 48 volts, like that they will convert it into. And also it's this high voltage also creating from here side only.
So this was a briefing about the instrumentation part of a C arm actually. So any doubts in this? If not, I can proceed further with my other presentation. Yeah, I think there are no doubts here. So with this view, I'm proceeding right now. So with this, I conclude my CM session basically. And apart from which, whenever we are into design or we are into architecture or evaluation or validation of any device, we will have to take few things into concern. So during this COVID situation, we were able to manufacture a numerous number of ventilators. So I have one such CCTV footage of use of a ventilator in an ICU in Gujarat, which I just want to share with you right now. After that, I will give another video actually, just 2 more videos.
A day after Central Gujarat's biggest public hospital witnessed a fire inside the intensive care unit of the COVID hospital, CCTV footage of the incident emerged on Wednesday, revealing that the fire was not from a short circuit, but because of a ventilator placed inside the ICU-1 unit located on the first floor of the SSG building. The footage, which was widely in circulation, clearly shows that there was a kind of blast inside the ventilator, after which the fire started, resulting in panic among the staff and patients present inside the ICU. The CCTV footage shows how the staffers bravely rescued the patients one by one, even as fire had started spreading inside the unit. It is a possibility that the ventilator caught fire due to heating, but the exact reason can be known only after the forensic investigation is done. Forensic experts' help has been sought for the same. The Casualty or Trauma Center of the SSG hospital, which houses the COVID-19 hospital, had provisional no objection certificate of Vadodara Fire and Emergency Services, as the firefighting equipment was intact and in working conditions. Officials maintained that a 4-member committee is probing the reasons behind the fire.
This is not just a video where we will have to truly understand why this has happened. Probably this would have been because of exposure of oxygen near the SMPS or power supply unit or something like that. The idea of showing this video to you is that we will have to take utmost concern whenever we are designing or evaluating a ventilator or any other device for that matter, not only ventilators. So there are few parameters which needs to be taken into concern, which can be seen now. So with this, I conclude my session. The basic idea of having this electrical safety video is that whenever we take into testing or validation or to design, we must be conscious enough to take these parameters into consideration, not just for ventilators, but for any other matters, including radiological equipments or any other equipments. So with this, I conclude my session. Any doubts, you can please ask me. Sudha ma'am, I conclude my session here.
Yes, sir. Yes, sir. You can proceed.
Participants, and please, if you have any queries,
Sir, you can proceed, sir.
Ma'am, I have concluded my presentation.
Yes, sir. Yes, sir. Yes, sir. Sure, sir.
Shall we leave then? Is it okay for me to leave?
Sir.
Ma'am, I have completed my presentation.
Okay, sir. Make conclusion, sir.
Is it okay for me to leave now?
Sir, up to 11 o'clock, your this session time, sir.
Okay.
So you can conclude, sir. You can conclude, sir.
So further to my session, I would have a briefing here for conclusion. C-arm, again, is just like any other radiological device, a normal X-ray, where the both source and the detector are being mounted over a C-shaped arm, so that there is a parallel movement of both source as well as the detectors. So that is the basic idea here. Otherwise, the radiological safety is of highest concern. One thing which we fail always is that we will be simply exposing ourselves without using any lead aprons or any other safety devices, which needs to be avoided. Whoever is actually needed there can alone be there while taking an X-ray or a C-arm, any radiation exposure for that matters. So otherwise, we will have to be much more concerned about the exposure parameters, the radiation dosimeters, to ensure that the technician is being least affected by the exposure, which may be even carcinogenic. Okay, so I would like to conclude here with the last presentation where
so participants, and if you have any queries, you can unmute yourself and you can ask the queries, or you can use the chat box.
Just like other imaging equipment that produces X-rays, the radiation safety goal for C-arm users is to keep radiation exposure as low as reasonably achievable, or ALARA. To help you accomplish that goal, we want to share 4 safety principles that reduce exposure for both techs and patients. First, proper distance. The rule of thumb for maintaining proper distance from a radiation source is to be as far away as you can. If the work you're doing doesn't require you to interact with the patient during radiation exposure, we suggest you take advantage of the full length of your hand or foot switch cable and stand back. Second, proper shielding. Whenever you work with a C-arm, it's important to wear personal protective equipment to reduce radiation exposure. This almost always means a lead apron, but can also include a thyroid shield, glasses, or gloves. If your facility has one, you may also be able to stand behind a leaded glass shield for even more protection. You should also always wear a dosimeter when you use a C-arm. This device measures the amount of radiation you're exposed to, and checking it at regular intervals lets you know if your safety procedures are effective. Requirements for room shielding vary from state to state, so you'll need to contact your state Department of Health for those details. Third, proper exposure time. Not all images can be acquired in the same short X-ray burst, but techs and doctors should only shoot X-ray for as long as it takes to get the images they need. Be sure to keep your applications training in mind too. Proper patient position helps to avoid retakes and extra shots that add to overall radiation dose. Finally, proper training. Don't assume everyone on your team has received proper radiation training before they joined you. Don't assume that your experienced techs couldn't use a refresher either. Lax practices can become habits before we realize it. If anyone at your facility needs radiation training, you can check out our course at training.blockimaging.com. If you have any other questions about any of the radiation safety tips we discussed today, we'd be happy to help you get answers. Thanks for watching, and remember,
Sir, excuse me, sir.
Yes, ma'am.
Sir, one question from chat box, sir. Dr. John Dansley is asking, only taking care of the radiation, but what about the earthing?
Yeah, that's a very nice question to answer actually. As we are particularly focusing about C-arm or any other radiological equipment, I was talking all about this radiation. But earthing is a very vital thing which needs to be seen for any medical device, for that matters, not only for medical device, for any device actually. So even when we are trying to test or validate an equipment, apart from the functionality test, what we were talking is all about functionality test. But apart from this QA or functionality test, this electrical safety, whether it is pertaining to IEC 60601 safety standards, is a very mandatory thing, and based on which equipments are also classified into class A, B, C again. So you have to categorize your equipment under which category it is coming. These are all class B actually. So there you have to satisfy your electrical safety parameters when you are into validation or manufacturing of these kind of equipments. Earthing is very important. The one common thing which the installation engineer fails to do is they will not be checking the neutral earth leakage voltage, number one. They will fail to check the chasis current leakage. What happens is sometimes you will not be connecting the earth cable. Earth cable has to be connected from the metal chasis to your earth point. In the theater somewhere you will be having earth point or any other metal ground, you have to connect your earth metal chasis or earth point from your machine also. If you fail to connect it, sometimes what happens is if the neutral earth leakage is very high, for sure the technician or the person who is operating will be receiving some shock which can be given as a complaint. If such is the case, you will have to focus on proper earthing. It is a very common problem not only for a C-arm but for any device, most commonly in patient table, in OT table, we will be getting this problem, where the problem will be that a new engineer would have gone for installation, you would have not connected that earth cable properly. So that's a very good question which needs to be addressed everywhere. I think I have clarified your doubts, sir.
Yes, sir. See any queries from the participants? So So thank you, sir. Thank you.
Yes, thank you, ma'am. Thank you. I'm leaving the meeting, ma'am. Thank you.
Sir, excuse me, sir.
Yes, ma'am.
Be there, sir. The vote of thanks will be there.
Yeah, okay, okay, okay. Yes, sir. Dr. John, sir, I see a question. Is there any certificates for devices for earthing? It has to be tested by a properly accredited laboratory for IEC 60601 certification. It should satisfy this parameter and then only it can be used for practicality. It can be commercialized or it can be used only after uh, this certification of it should satisfy IEC 60601. Is it okay, sir? Yeah, I understand your mic is not working. If I am not clarify your doubt, you can please post your next queries. Thank you.
Shubha, ma'am.
Yes, ma'am.
Okay, carry on, ma'am.
Thank you, ma'am. It is indeed a great pleasure for me to deliver the vote of thanks on behalf of Department of Biomedical Engineering, PSNA College of Engineering and Technology. I would like to thank Mr. Venkataraman, Managing Partner, Biovision System, Chennai, and Zagir Hussain, CEO, Biovision System, Chennai, who gave a very nice talk on CR machine and the ventilator. I'm sure the participants would be highly benefited from your talk. Thank you very much, sir. This is really a very informative session. Thank you, sir.
Thank you,
Thank
ma'am.
you.
Thank you for the
Thank you.
opportunity.
Okay, sir. Thank you, sir. Thank you very much, sir.
Thank you, ma'am.
Thank you.
Participants, the next session will start at 11:30 a.m. Thank you.
Hello.
Hello, ma'am. Am I audible, ma'am?
Yes, ma'am. Now I can hear you. How about my voice?
Okay.
Is it audible, ma'am?
Audible only, ma'am. Audible, ma'am. Okay, ma'am.
Right, ma'am. Ma'am, can you check my presentation whether it is
It is visible only, ma'am.
visible?
Clear.
Now I'm going for slideshow mode.
Yes, ma'am. Yes, ma'am.
Right.
It is in slideshow only, ma'am.
Thank you. Thank you.
Okay. Good morning, all. I have immense pleasure to introduce guest of this session, Dr. M. Monica Subhashini, Associate Professor, Department of Control and Automation, School of Electrical Engineering, VIT Vellore. Dr. M. Monica Subhashini is a motivated researcher with teaching experience of more than 10 years. She received the B degree in Electronics and Instrumentation from Korea Institute of Technology, Badia University, and ME degree in Applied Electronics from St. Peter's Engineering College, Anna University. Her doctoral degree was towards medical image analysis and received PhD in 2014 from VIT University. In 2008, she joined the Department of Electronics Engineering, Electronics and Communication Engineering, Savita Engineering College as a lecturer, and was a part of the research and development team led by Professor Balasubramaniam Piratla, scientist ISRO, professor at Savita Engineering College, and completed innovative projects. She also collaborated with Cisco Systems in establishing Communication and Networking Lab. Since 2009, she has been with the Department of Electrical Engineering, VIT University. Her current research interests include medical image analysis and modeling, medical diagnostics and biosensing, bioengineering, artificial intelligence, machine learning, industrial and human systems, tissue health monitoring, and human vital signs measurements. Dr. Monica Subhashini is a member of Soft Computing Research Society, India. She has received Ghanaian Young Technological Innovation Award 2014 for a project titled Voice Activated Safety App by Mithila Harish under her supervision. Also, she is leading a team of motivated students in research who regularly participates and fetch laurels in various competitions like hackathons, symposiums, and international conferences. Based on her specialization and research interests, she has authored more than 45 national, international journal papers, international national conference papers, and book chapters. Most of them are published in leading peer-reviewed referred impact factor journals. She is also a potential reviewer in various journals and conference committees. With this brief introduction, I hand over the session to Dr. Monica Subhashini. Welcome, ma'am.
Thank you so much for the wonderful introduction, ma'am.
Thank you, ma'am.
Good morning, everyone. Today, we are planning to discuss about deep learning techniques on medical imaging. Initially, I wanted to throw some light on neural networks. Then slowly, we'll move towards the applications. Finally, we can end up with deep learning. So it's going to be a combination of theory and some practical exposure. We know about the disciplines that contribute to artificial intelligence related to medical field. You can see biology, physiology, anthropology, philosophy, neurology, psychology, everywhere. Right now, there is a vast usage of artificial intelligence. And behind this artificial intelligence, what is the fundamental concept? You want to apply artificial or any automation technique, what is the concept behind? You need to know about neural networks. Neural networks would be the base for any advanced artificial intelligence technique. That's why let's begin with the neural networks. And what are the basic tasks that is going to be performed with the machine learning and deep learning? It's going to be pattern matching, classification, optimization function, approximation, data clustering. So coming to the core topic, medical imaging. Mostly we are going to work with classification techniques, and we do have predefined algorithms for classification problems. These tasks could be difficult for traditional computers because we are going to train a program or a machine to think like a human being, to take decision on its own. As a human being, I can decide whether there is a tumor or not, but how come a machine will decide? You need to train the machine to incorporate or to perform these tasks with 100% efficiency and accuracy. So let me start with a base of neural network. As a faculty members and research scholars, we would have come across all these information. But anyways, I just wanted to revise these topics just to brush up all these topics. It would be useful for your research anyways. The neuron is the basic unit of a brain. Billions of neurons are available, and brain is the controlling unit of our entire human body. Everyone are aware about this. So actually what is happening inside the brain, the individual unit of the brain, the neuron, the structure is given here. The dendrites or the branches, they receive the information from the neighboring neuron, and the information is processed in the cell body, and the processed information is transferred through axon. And we do have a junction which is known as synaptic junction. The information would be transferred to the neighboring neuron here at this junction. So depending upon the time, these impulses are produced. And maybe if you measure the amplitude of these impulses, it's going to be in millivolt. Electrical signals are the impulses produced or created in the brain. Okay. And that is how we feel the pain, or any instruction would be passed on from brain to all parts of the body with the help of these electrical signals. So with this concept, we are going to develop an artificial neural network. So this is a pictorial representation of a relationship between a neuron and an artificial neural network. As I told you, the dendrites or the branch-like structure, they receive the information. So let us consider those to be the inputs. We are going to feed in the input. Next, the cell body can be related to the node where the processing happens. Receiving the information and processing happens in the node. Then the transfer of information happens in the output part. This is the basic architecture of an artificial neural network. So in that case, let me represent an ANN here. N number of input signals are assigned or received to the cell body or a neuron. The specialty is you need to assign individual weights for each and every signal. I just wanted to give importance to one of my relative. What shall I do? When you're welcoming, we will definitely give some extra preference to our relative, who is very close to heart. Similarly, if I want to give an importance to the first input or the last input, you can do it by updating the weights. Either you can apply positive weight or negative weight. That is, you can assign constant values. Assign weights to each and every input signal. Then process the input signal here in the neuron, and the output signals are produced. So as per the previous discussion, dendrites are the receivers. Soma is actually the neuron cell body, which sums all the input signal. Axon is the transmitter, and point of transmission is going to be the synapse. So based on this information, the biological neuron has been converted into an artificial neuron. And all the algorithms are definitely depending upon this particular concept the scientists have developed. This is the basic concept behind any artificial neural network. Let us see the structure of a artificial neural network. We are receiving the inputs, then we process the inputs, then we transfer the outputs. So to be more in brief, this is an example to process the inputs. Consider two inputs, maybe a logical AND gate or OR gate problem. If you just consider, there are two inputs. Consider OR gate, x1, x2. Then for x1, assign the weight to be w1 and x2 the weight to be w2. What would be the formula for summing up this particular informations? So you can apply the summation x1, the product of input and the corresponding weight, and x2 into w2. You can just check out the formula here, x1 into w1 plus x2 into w2. So in that case, summation of product of input and its respective weights. That is how we calculate the net input. Yn is otherwise known as net input. So once you complete this particular process, what about Y? How we are going to generate an output? As we know, we are talking about machine learning. Machine has to answer either yes or no. It cannot take many decisions. If it is going to be specifically on a classification problem, whether tumor is present, yes. Whether tumor is present, no. So there are two answers, either yes or no. So how are you going to make it fire? The neuron should fire to produce the output 1 or should not fire to produce the output 0. So you can apply this Boolean logic, high or low logic, 1 or 0. Suppose you consider bipolar, it would be 1 or minus 1. If it is unipolar, 1 or 0. These are the respective outputs for any artificial neural networks. If you have, ma'am, what about multi-class problems? What we will do? Yes, you have to very well change the activation function such that it can support a multi-class problem as well. So the following tuple will be giving you more clarity on activation functions. Let's check the formula given here. Y is equal to application of any activation function to the net input results in the output Y. You need to differentiate both the Y's. That's why we use Yin and Y to differentiate net input with the neuron's output. For example, consider a pure linear equation. You know, Y is equal to mx plus c. Okay. Consider, you ignore the c part. We have Y is equal to mx. So m would be considered as the weight and input would be x. So Y is equal to mx. This is how we are going to relate the equation to a development of an artificial neural network. Let us move on to the activation function. As I told you, this activation function play a major role in prediction or classification or in any problem statement. First of all, there are two major divisions. One is hard limiting activation function, and the second one is soft limiting activation functions. And what is the difference between hard limiting and soft limiting? You can see this particular diagram for more understanding. Step function and signum function comes under hard limiting activation function, whereas sigmoidal function comes under soft limiting function. How? Based on the response of the curve, you can decide whether it is hard limiting or soft limiting. Let me move back to the types of activation function. So it's going to be bipolar continuous. When it is known as bipolar continuous, the minimum and maximum range is going to be defined. Let us consider sigmoidal function. So the diagram is given here, sigmoidal function. Here, this particular graph represents unipolar sigmoidal function. What is the difference between bipolar and unipolar. If it is unipolar, minimum range is 0, maximum is +1. If it is bipolar, it starts from -1 to 1. The output would be lying between this range. And coming to the calculation of net input, we cannot follow the same criteria where we discussed before. Calculation of net input, application of activation function. When you just check the signal graphical representation, you can see this x-axis denotes y-in. X-axis denotes y-in and y-axis denotes the output. So with respect to the net input calculated, the output is produced. Substitute the value of net input here, 1 upon 1 plus e to the power minus x, that is x denotes the net input or y-in. You get the output signal. Y sigma gives you the output signal. Based on that, the response of any classifier can be determined. Coming to the hard limiting function, signum function, you can check out the net input. Net input, when it is greater than or equal to 0, the output is 1. When it is less than 0, the output is -1. What is this 0? Why suddenly we are talking about 0? What is the purpose? It's going to be the threshold or theta, and it is necessary for any activation function. So while you're programming, fixation of theta is really important. Decide or choose theta as per your problem statement. Anyways, for signum function and step function, the theta threshold would be by default 0. So based on that, the output can be produced. So relate this activation function with the previous chart. So now, after application of signum function, maybe the net input value would be 0.5. So apply the activation function. Yes, 0.5 is greater than 0. So what is the output? +1. Y would be 1. This is how we put and we train the network to think like a human brain. Hope this concept is somewhat clear. Maybe if you have any doubts, we can discuss in the questionnaire. So here, a common model of neuron is shown. All the inputs are summed up. Then with respect to the net value, we are going to apply the activation function. It is also known as threshold logic unit, and the output is generated. And a basic artificial neural network, a basic neuron is known as perceptron. And this perceptron can be acting as a linear classifier. Perceptron is very well suited for a linear classification. Multi-class problems would be supported with the help of continuous perceptron. Based on the activation signal we just saw, sigmoidal functions. You can apply sigmoidal functions. Just check out this formula, f of net equal to 2 upon 1 plus e to the power minus delta net. So this denotes bipolar continuous sigmoidal function. So based on the need of the user or the programmer, please choose the app computer is given here. This is for your information. What is the difference between the brain and whatever we are going to develop, the artificial neural network? Few nanosecond massive parallel processing can be done with an artificial neural network. Definitely we are competing with the brain. We are going to try to improve the artificial neural network to exceed the human performance. That is what right now it's happening. Storage capacity is given here. As a human being, we have loss of memory, but in artificial neural network, we don't have loss of memory because we are going to save all the informations. Fault tolerance, no fault tolerance, and complicated in brain. Okay, suppose if you're going to think too much, it will be affecting your system, entire system, but that is not going to be happening in our artificial neural network. This is a comparison. Okay, let me move on to the next information about ANN. Basic models. What are the basic models of ANN? There are models, predictions are made, and based on the learners discuss about, based on the interconnections, what are the types of networks available. First one is feed forward, next one is feedback, third one is recurrent neural networks. So as usual, we do have single layer neural network and multi-layer neural network. Under each type, we do have single layer and multi-layer. What is the difference between single layer and multi-layer? Let us check out an example on this. Single layer feed forward network has one input layer and one output layer, right? We receive the signal and we process the signal, and output is produced with only two layers. There is a difference between layer and neurons. This particular input layer consists of number of neurons. When you are going to design an input layer, you are going to decide the number of neurons based on the number of input signals or based on the number of feature vectors. Images can be converted into vectors, and for example, let us consider x1. This is going to be an individual vector. x2 is going to be an individual vector. xn is going to be an individual vector. Okay, so this input layer contributes n number of neurons or nodes, and output layer, again we do have m number of output neurons. The notations are very important. Usually in neural networks we use n to represent number of input neurons and the alphabet m to represent the number of output neurons or nodes, and we get the output. You can just check out to give more information on this. I wanted to explain this. You can see W11 has been assigned as a weight. So the explanation, or if you want to relate this with the input and output, the first input node is connected to the first output node. That is how we differentiate weights. We differentiate weights and we assign corresponding to input and output. So here, the number which denotes, this is going to be the W21, for example. The second output node is connected to the first input node. Even you can decide, you can just reverse it. You can assign this as W12. If you want to continue, you have to proceed in the same manner. Consider first the input node to the corresponding output node. It's up to the user to decide the pattern. Next one is multi-layer feed-forward network. Here, apart from input layer and output layer, we do have a hidden layer. What is the purpose or importance of this hidden layer? It can be used for complicated problems. All the processing calculations are done here in the hidden layer. That's why we just differentiate simple classification problem, or we perform simple classification problem with the help of single layer networks. And whereas complicated problem, for example, back propagation networks, if you want to apply back propagation algorithm, definitely you have to move on with multi-layer feed layers has to be included. And maybe you have experience in working with MATLAB. You could have, as a user, we have to define the number of hidden layer or hidden neurons. Sorry, here we do have one hidden layer and multiple neurons are available. So how many neurons you have to define? So coming to feedback network, you can check out what is the difference. We don't have any feedback here in feed forward network because I don't bother about the error. Just we want to classify. But how to rectify the error? Maybe few faculty members are from control systems. You are you know very well about the errors, how to reduce the error. You have to give a feedback to correct the signal, to rectify the error. That is what is going to happen. So here, part of the output or the output is fed back to the input signal. And why we need to feed back the input signal? To correct the error as usual. How it is going to happen? The weights would be updated, change the weights. So right now, this set of weights is not suitable for the desired target. What shall I do? Let me update the weight, either increase the weight or decrease the weight and check out. Based on trial and error measures, you can reduce the error. That is how we are going to design a feedback network. And back propagation algorithm is a very good example for feedback network. This is another type of network under feedback layer itself, lateral feedback. Instead of feeding the output directly to the input, we are just partially feeding the feedback to the hidden layer. That is where processing is happening. So in the processing elements, the output is fed and we can update the weight depending upon this information. Third type is recurrent networks, and we do have different types of recurrent networks. Right now in deep learning, most of the researchers are working with recurrent networks because memory-based problems can be solved using recurrent networks. First type is single node with own feedback. Next one is competitive nets. Third one is single layer recurrent networks. Then multi-layer recurrent network. These are the 4 types of recurrent networks. And right now, based on the interconnections, we saw what are the broad area among the networks. Next, we'll move on to the learning rules. So based on the learning rules, how this classification or problem solving is going to happen. We have 2 types of learning methods, basically. One is parameter learning, and the next one is structure learning. In parameter learning, you would have come across, the weights are updated to rectify the error. That is known as parameter learning. What about structure learning? Change in network architecture or change in network structure. This is the second type of learning. Then coming to training method, how are we going to train a network or develop an algorithm with the help of training? We do have 3 broad areas or major areas. First one is supervised learning. Second one is unsupervised learning. Third one is reinforcement learning. These terms are really familiar, you know, based on this. The first type, supervised learning. We know from the childhood, it is not easy for us to learn on our own. Initially, the parents or grandparents, there are teachers. Everyone will definitely agree. They used to start from maybe 8 months or 9 months, 10 months. They started teaching us to pronounce few alphabets, few words, Tamil words, English, based on your mother tongue. We start learning from our parents. Then maybe after 3 years, you're being sent to a school and your teacher is going to train you. The brain is fresh and the informations have been provided to the student or to the brain with the help of a supervisor or a teacher or a parent, right? And that's how the child learns. Similarly, the algorithm or the machine or a network has to be trained because it is fresh and no information has been given. So we need to train it. So what is the only solution? You need to train with a target vector. For this particular input vector, what is the corresponding target vector? That is how the machine will start learning. Okay, I'm going to receive an image. If I receive this particular image, what would be the output? That is how you are going to train the network with a large number of inputs. So feed in or train the network with images with no tumor. Then train the network with images with tumor. With and without tumor, you just train. Then you classify, define the target. If it is with tumor, then obviously the output should be 1. If it is without tumor, the output is 0. Apply unipolar step function. That's it. The problem is solved. The classification done. The only challenge is convert the image into vector using some techniques. You can apply principal component analysis or ICA. You can apply ICA. Then dimension reduction techniques. There are many techniques separately available for this conversion process. Then easily you can develop a network. So basically the information, you can check this diagram. the actual output is compared with the desired output. Desired output is actually the target. The target is actually the desired output. So just compare the actual output with the desired output and find out the error. So based on the error, you update the weight. That's how we are going to reach 100% accuracy. It is not easy to achieve 100% accuracy, but we are going to try and try to achieve above 95% at least. There are practically many challenges, but anyways, we have to proceed. No other option. If you're working in this field based on trial and error methods, you can just continue. Coming to unsupervised learning, we don't have a target. Without target, I have to learn. What would be the only solution? Automatic learning has to happen. All similar input patterns would be grouped together as clusters. Consider a pond. All the fishes would be swimming together. They will not go and just swim along with the frog or with the snakes, right? It is dangerous for them. Same example can be applied here. Same birds flock together, correct? In that case, all the similar patterns would be grouped together and come up with one group. Clustering, it is known as clustering. So multiple clusters formed, and those clusters would be finally considered as classes or the output classes. So here there is no output. Instead, the similar patterns would be grouped together. That is the concept behind this. So a very well example is self-organizing maps. There is one particular algorithm where I used to teach students a coherent self-organizing map. So, and this can be applicable for image processing to discover regularities, patterns, features for the input data. I have some examples on that in later slides. We don't have complete information on the output. I don't know what would be the target, but I wanted to complete the problem. Only partial information or critical information I have learning. Based on the partial information, finding the shortest distance to reach Salem. So I have to check what are the possible conditions, how many kilometers. When I check, and I'll finally come up with one solution, and that would be a good example on reinforcement learning. So this particular learning is applied only when less information is available about the target output. Path planning, routing algorithms. Right now, BTech students are busy with these type of projects, path planning and robotic movement, maybe traveling from one place to another. You have to transfer some loads. So automatic bots are constructed, and reinforcement learning can be applied to train those bots. Few examples and algorithms coming under supervised and unsupervised learning. First and foremost, Adeline and Madeline. Adeline is a simple neural network. When you're going to combine multiple Adeline, it will become Madeline. Complicated problems can be solved using Madeline networks. Activation function is bipolar. 1 or -1 would be the output. Next, famous one is perceptron. For a linear classification problem, you can choose perceptron. Next, back propagation algorithm for solving convolution networks. Then coming to unsupervised or clustering networks. Competitive learning. What is the inputs? Finally, I need to choose one winner. I have to declare one winner. So such type of problem statements can be applied using competitive learning networks. Winner take all is one example. MaxNet, Mexican Hat, HammingNet. These are the algorithms which come under competitive learning networks. Coherent self-organizing, learning vector quantization. Learning vector quantization can be applied for this tumor problems, whether tumor is present or not, size of the tumor, low or high. Those type of problems can be solved using learning vector, then Hebbian learning rule. Next, important information related to imaging techniques. It is actually based on recalling techniques. Neural processing, if you're going to consider the neural processing or the computing procedure, there are three basic forms of neural information processing. First one is auto-association, next hetero-association, third one is classification. A given input pattern is square is available. It is fed into a neural network, and if you check the database, already we have saved a few patterns. This is must. During training process, we would have saved the information in the database. Now the received input pattern will be compared with the existing database, and it will be associated with the most similar pattern. If a pattern similar to the member of the stored set is presented, an association will occur with the input. So the closest pattern would be declared as the winner. What would be the application of this particular network? Or restoration of paintings, or if you want to go with archaeological projects, if you want to identify the patterns, we don't have the full form, only partial information is available or distorted image is available. You can utilize such type of algorithms for this historical projects. Right now, in funded projects, there is a lot of scope in this particular area. So just giving you a suggestion, you can just concentrate on that area as well. The next type is hetero association. So already we do have some patterns. Distorted input pattern may cause correct hetero association at the output. It might not be the same one, but the related pattern or the family. Maybe if you are going to send a square, really choosing the similar pattern in their, it is almost similar to 8, and 8 would be declared as the output. And the triangular pattern, it is almost similar to a circle, so the output would be a circle. Likewise, pair of patterns are stored, and the most appropriate one would be declared as the output. Next one is classification. Using class membership, we are going to differentiate. As I told you, for tumor, it is going to be 1. For non-tumor, it is going to be -1. So assign the class number, and accordingly you can classify. So what are the important terminology of this artificial neural network? Whatever we have come across, this is just going to sum up. First one is weights. Next is bias, threshold, learning rate, momentum factor, vigilance parameter. You have to know all these when you're working with important. You're going to connect the inputs with the links, connection links or weights. And depending upon the weights, you can just improve the importance or decrease the importance of any input. You can represent the weight as a matrix, and this is how we work in MATLAB with the help of weight matrix. Maybe sometimes the input pattern would be considered when you're going to multi. Sometimes, depending upon the algorithm and the pattern, weight matrix would be considered a transpose, then you get the output. So already we have discussed about the activation functions, identity function, step, binary, unipolar, bipolar, continuous, discrete. This is what? This is the major factor which will decide the output response of a neuron. Next, what about bias? Apart from weight, there is another challenge or suppose your net input calculated is not reaching the target, I cannot modify the weight, I cannot change the input. What would be the solution? So this is how, or this is where you are going to use a weight. It is going to be an external added. So previously we dealt with the linear equation. Y is equal to mx. Now y is equal to mx plus c. So this c can be considered as the external weight or a constant weight, or it is known as bias. Now you can just check out y is equal to mx plus c, where m is the weight, x is the input, the c is going to be a constant value. And threshold, we know, set theta depending upon the output, required output. The activation function or unit needs threshold. Definitely it needs a threshold. So define a theta or threshold by the user. You have to choose the threshold. Coming to learning rate. Alpha is going to be the learning rate. It is used to control the amount of weight adjustment. Instead of trying out multiple iterations, you can adjust the processing speed with the help of learning rate. Usually, we used to set the learning rate from 0 to 1. Within 0, maximum is 1. Within that, you can choose any learning rate, alpha. So right now, we just discussed about the neural network. We replicated a human brain, and we have designed an artificial neural network which will solve many classification problems, and with the help of positive weight and negative weight. And finally, we are applying an activation function to declare the output. This is going to be the summary of the neural networks, whatever we have discussed till now. So now this is the time where we are going to move on towards process flow in machine learning and deep learning. So this particular program, it is based on deep learning. But before moving to deep learning, you should know about machine learning. What is the difference between machine learning and deep learning? Obviously, it's going to be a similar process, but deep learning is a bit advanced level. In terms of processing time, training time, we can reduce the training time. The speed can be increased. The performance of the algorithm or the network can be increased in deep learning. So let us start with machine learning. This is one particular case study I've chosen to discuss. When we talk about medical images, before starting with the processing, collection of medical images, it's going to be a challenging task. As everyone know, when we have a collaboration with an hospital, we have to follow many protocols, and confidentiality is really important. You cannot disclose the information. So considering all these parameters, getting data set is very challenging. Right now, there are many online platforms where they offer us free data set. So now, right now, we can complete the training process with the available online resources. Then you can move towards testing process with the real-time data. That is also one possibility, but there should not be much difference between your training image and testing image. Then it will affect your accuracy. So starting with pre-processing, we will be following towards or proceeding towards feature extraction. Then after feature extraction, feature selection, the most important features would be selected. That would be supporting the classification. So this particular process, pre-processing, feature extraction, feature selection, and classification, is very important when you compare machine learning with the deep learning algorithms. You have to apply individual algorithms for all these processes, for pre-processing, extraction of features, and the selection of features. Individual algorithms have to be applied in machine learning. But in deep learning, one single network can be applied, which will complete all these processes. So this is how we reduce the time. No need to work separately. But during my PhD, machine learning was really demanding. So I applied multiple algorithms for all these processes. So right now, my scholars are working with deep learning because it is not necessary right now. It is not necessary to work individually. Where we get
Ma'am, excuse me, ma'am.
one algorithm which will perform all these tasks.
Ma'am,
There is a major difference between machine learning and deep learning.
ma'am,
So
your
what
voice
is
is
deep
breaking.
learning and why we have to go for deep learning?
Hello, ma'am.
No need to work to
Excuse
extract
me, ma'am.
the relevant features separately. You will be getting.
Excuse me, ma'am.
Ma'am, voice is breaking.
Yes, ma'am.
Your voice is breaking, ma'am.
Can you hear me now?
Okay, ma'am. Sometimes it is breaking, ma'am, your voice.
Okay. Due to internet connectivity issues, ma'am. Now I've changed my connection to another network.
Okay.
If you have still have a problem, please let me know.
Okay, ma'am. Okay, ma'am. The sharing of slide is okay, but your voice is
Okay,
sometimes.
but voice is breaking. Okay. Okay, now let me proceed. What about deep learning? What is the important informations you are in need while you're going to work with deep learning? First of all, collect the raw images. Feed the raw images. No need to pre-process because pre-processing would be taken care of deep learning itself. We need only a deep neural network that will learn the features automatically. But the only thing, you need thousands, hundreds or thousands of images for best results. And we cannot work with a normal laptop. We would be needing a high performance GPU. These are the two necessary requirements to work with deep learning. Using a neural network architecture, what we are going to do, we are going to implement a deep learning network, combine more number of layers. More number of layers will result in deeper network. If you're going to include 2 or 3 layers, then it is coming under traditional neural networks. While suppose if you're going to apply deep neural networks, it can have hundreds of layers. This will speed up the process. I've given a simple representation, graphical representation, why deep learning is necessary. The performance is less in older learning algorithms, whereas when you apply deep learning, you can improve the performance of your network. That is how we are going to justify usage of deep learning, as well as when you're going to increase the amount of data. As you increase the amount of data, the performance would be improved. This is very important. Now you can just see the difference between simple neural network and deep learning neural network. Only one hidden layer is available here, whereas in deep learning network, more number of hidden layers can be included, and it is included to simplify the process. This is the major difference. Moving on to applications of deep learning. Okay, we are talking about deep learning, where it is utilized. The first and foremost, first top application is healthcare. And today's topic and this FDB is related to medical imaging on deep learning networks. Yes, of course. there are n number of problem statements which seeks help for the application of deep learning. Next, going for self-driving cars. In leading car manufacturer companies, there is a separate department on working with artificial intelligence. They wanted to automate many processes in any car. Okay. And artificial intelligence is applied with the help of deep learning networks and algorithms. Then news aggregation and fraud news detection. This is a recent problem. Suddenly some news will be received. People would be posting in WhatsApp status and Facebook. And after half an hour, then it would be a fake news. People do this intentionally. Okay. So in media or in other public domain, there are few apps that will detect whether the news is fake or is it original. That type of application is also right now is much needed. Natural language processing. This helps in kids, assistance, entertainment, visual recognition, fraud detection. These are the top applications. And to be more specific about healthcare, to analyze blood samples, then to track glucose levels in diabetic patients, to detect heart problems, then to detect tumors, image analysis is performed. Then you have to detect cancerous cells or diagnosing cancer. Multiple cancers or different types of cancers are available. So depending upon your area of interest, you can choose the problem statement and you can apply deep learning. This would be actually, it is not for the sake of completing any project. No, it's not like that. You have to come up with something useful to the society. Suppose if you're going to develop a computer aided system or assisting system, that might help a doctor. He might seek our help in saving the time. He cannot sit and check out all 1,000 images and identify the diagnosis or identify the disease. Instead, if you're going to develop an artificial intelligence system, he can finally go through the result and he can confirm. So this is very important. Doing something for the society is the need of the hour. That is how the funded projects have been approved by the government. They are seeking like, is your project useful? Which part of the group it is available, or to which group the project would be useful. Likewise, we need to target and work dedicatedly in this particular area. You can come up with beautiful solutions. So what are the resources for deep learning in healthcare? You need to work with ultrasound images, MRI, magnetic resonance images, positron emission tomography, mammography, computer tomography, X-ray images, hemotoxin and ozone histology images. That is, after performing biopsy, the tissue would be viewed under a microscope. That is actually known as biopsy. You will tear a part of tissue and check under a microscope. Then those images actually comes under histology, histopathological images, then optical images. I have few case studies related to these research. I won't be boring you much. I have some diagrams, pictorial representations. This is the problem statement of my PhD. I worked with one type of tumor, brain tumor, which is known as astrocytoma tumor. It is going to be a primary tumor, and 80% of tumors belong to this particular area. 80% of brain tumors comes under astrocytoma. We do have 4 grades. First one is the first stage, grade 1, grade 2, grade 3, and grade 4. These are the 4 different types or stages of astrocytoma. So the problem statement was identification of the stage, whether it is in the low grade or in the high grade. I combined the grade 1 and grade 2 as low grade, and grade 3 and grade 4 as high grade. That is how I chose to decide, because discriminating 2 and 3 was very difficult. So I just combined 2 with 1 and 3 with 4, and we came up with low grade and high grade. So just I wanted to share my simulation results. Initially, I applied watershed for segmenting the tumor. Then later on, it was not, the results were not promising. So I applied fuzzy C-means algorithm for segmentation. And then we applied a PCA and GLCM, gray level co-occurrence matrix. GLCM we just applied for extracting the statistical features. Then for feature selection, we went for shuffling frog leaping algorithm. And it was tabulated, and you can see for the low grade, when I calculate, this is the area. Area is actually the number of pixel of white tumor, like white area. The tumor was represented as white in color. You can just check out. And this tumor can be highlighted. So I just wanted to find out the area of white pixels. So here we got the information about area, mean, median, moment, standard deviation, skewness, variance. And similarly for high grade, again, the same technique were applied, and I got the features. These are all known as features. I applied feature extraction techniques to extract feature. What was the feature extraction? GLCM was the feature extraction technique I applied. Now, I selected one particular feature. Which one? The area. You can see considerable difference can be seen only in area. So starting from, consider few samples, starting from 1,659, 4,480. This was the range of low grade tumor white pixels. But in high grade, I saw it was like starting from 10,000 to 12,000. So for differentiating a low grade from high grade, this particular feature was helping us, and we selected this particular feature area for classification. And then what were the classifiers applied? SVM, support vector machines, learning vector quantization, and naive Bayes. These were the three classifiers I applied. And the number of training and testing images, if you consider, 164 out of 200, because I got very less number of images. So out of that, I just divided 164 as training, and I separated 36 for testing. This testing images should not be used during training. That is the most important thing. Only then you can check out. So out of 36, rightly classified images were 32. Because how do I know whether it is the right classification? I got the validated data set from a doctor, and based on that information, we validated our classifiers. So now only 4 were misclassified. Only 4 were misclassified. Efficiency was 88%. Error was 11%. And this was the elapsed time, and the process information is given here. LVQ was 91.6%, and neighbors 91%. Maximum during that time, with the help of machine learning and with the available data set, I reached only 91%. But if I'm going to apply deep learning, I can improve this accuracy and efficiency still more. But what is the challenge? The number of images. That is the challenge. Even now, I didn't get a proper data set from the hospital, because right now we're facing difficulties in accessing the data sets. That's why. When I move on to another example, this was my PhD work. Right now, I'm working on a project. You're now familiar why these online lectures are going on due to COVID-19 situation, pandemic situation. We are here in online mode. So what is the hot topic now? Many students, many faculties have come up with good projects based on the chest X-ray image data set. We are classifying like whether it is a normal or abnormal X-ray image. Based on that, we can just identify whether he is infected with COVID or not. Pre-processing, K-fold validation, training and testing. Finally, for the network, deep learning network, ResNet 50 is the one type of algorithm or one type of network which is applied for this particular problem statement. This is one methodology. It is not necessary they follow the same methodology. There are different methodologies. I'm just giving you an example. What are the areas where deep learning is applied? So here you can see the data set. multiple classes can be worked. Instead of first one, you can target, find out whether it is normal or abnormal. If it is abnormal, whether it is COVID or pneumonia, that is also a challenge. Right now, people are suffering with respiratory disease. We cannot say that he is having COVID. No, we cannot say, because most of the symptoms overlap. So based on the X-ray images, it's necessary for us to differentiate normal respiratory process or with COVID. We need to differentiate or distinguish. This is one particular task. Then there is another technique, color activation mapping. Based on this color activation mapping also, we can find out the probability of COVID occurrence. Next application, this is also my project. I'm just working on this. Temperature detection using deep learning techniques. The input images are from thermal camera. Thermographical images are available or obtained from a resource and those thermal camera images are processed. CNN, convolution neural network, is applied for processing the information or the image, and based on this, we are predicting the temperature of a person. It's not like in railway station or an airport. If you're going to walk in a crowd, it would be difficult for us to individually identify the person with the device, temperature detecting device. If a remote device is designed to capture the images and predict the temperature, we can identify the specific person with the fever and we can isolate him from the crowd. That was the objective of this particular project, and the others will not be affected because of this. So for screening, we can apply this particular technique. This is another research project I came across from the literature, just for your information, for malaria detection. Malarial detection, I got the image. This data set, it showed uninfected and parasite. So actually, what is the problem behind this malaria? This Plasmodium malaria is a protozoan that causes malaria in humans, and the symptoms would be very rare and we cannot identify it, but it would be available in the blood sample. In blood sample, it would be visible. So to differentiate or to classify from the blood sample, you can apply deep learning techniques. So generally, what would be the methodology to be followed when you're going to apply convolution neural network or any deep learning network? Load the database, first of all. This database should be validated one, cross-verified by a doctor, so that you will be clear, first of all. You should be clear. Without knowing the label, without knowing the classes, if you're going to train the system, then it is going to be utter flop. So let us proceed in this direction, validate the data set, then you create a separate folder for training database, testing database, and under training, it should be normal images, abnormal images. That is how you have to classify. So based on the previous problem, normal would be uninfected, abnormal would be this parasitized. That would be the abnormal class. So after loading or getting the database, then identify the class, visualize the images. You should confirm first. Then go ahead with pre-processing. Pre-processing techniques has to be applied and classification. So when you're going to apply deep learning, already we have pre-trained models that is known as, like one example is CNN, AlexNet, ResNet, VGG16, DenseNet. They're all available in even in our MATLAB or in Python. You have in open source, you have pre-trained networks. You can apply those pre-trained models and you can get the classification done. What about transfer learning approach? What is the meaning of transfer learning? What is it? How it is related to deep learning? When I'm talking about pre-trained model, we cannot apply the same or use the same pre-trained model in research, because we have to come up with our own, like with our own ideas. What is our contribution in research? Only then our PhD would be validated, right? So in that case, your contribution to the society or to the problem statement can be done with this transfer learning. You modify or improve the existing layers. the layers can be altered, and that is actually known as transfer learning. Your contribution to the, so increase the number of layers or you change the layers. That is how we develop this transfer learning approach. And another example for histological images. On all cancer patients, you can see the tumor would be cut out by a surgeon. Okay, thinly sliced, and when you're subjecting this under a microscope, you can see the samples. These samples will differentiate normal and abnormal or tumor and no tumor. This is how. And I got this data set from this portal .gdc.cancer.gov. You can even download the images, but it is available in SVS format. Actually, one image itself is larger than 1 GB, and you need to apply dimension reduction technique for this to reduce the size of the image. This is the zoomed version of the particular tumor area. And what would be the methodology? This is just modify the network by removing the last 3 layers. For this particular problem statement, the authors, what they have done, they have applied a transfer learning technique with AlexNet. AlexNet is a pre-trained model, and for that they have applied the transfer learning and came up with classification. I just wanted to show the classes for this particular problem. We had multiple classes. The class labels are given here. Adipose tissue, you can differentiate adipose tissue, no tissue, background, debris, lymphocytes, mucus, muscle, normal mucosa, stroma, tumor epithelium. These are all the available information present in that particular image. And from one single image, we can differentiate all these layers or all these tissues. This was one particular problem statement. Next, related to diabetic retinopathy, few faculty members and research scholars would have been working with optical images. Even there, when I researched in the internet, I saw few papers and 5 classes. The output classes are 5 multi-classes. So first one was without diabetic retinopathy, that is normal image, then mild, moderate, severe, and the last one is proliferative. These are the 5 classes where deep learning can be applied. And when I found out the methodology, they applied a CNN, deep convolution neural network. More number of layers were included. And lastly, you can see fully connected layer. So usually in deep learning network, this is the last layer which will perform the classification. Labeling will happen here in the last layer. I've given the model flow steps here. Since we are running out of time, I just wanted to complete. Next one for Alzheimer's. Later I can share this PPT for your reference and information. Next particular disease is Alzheimer's. So this Alzheimer's, if you choose this particular problem statement, gray matter and white matter analysis is very important in Alzheimer's. That is how we decide whether the person is infected or not. That can be done from a MRI image. So I just wanted to show this is the sample Alzheimer's image. Now we need to find out the change in the white matter. So the image volume, we have to consider the image volume and voxel based feature instead of pixels. When we are moving on towards 3D imaging, we have to refer voxel based feature, and these features are used to classify the Alzheimer's disease stages. So this was the process they followed: independent MRI, pre-processing, trained model, then the physician decision were taken care of. We have to consider the doctor's advice as well. His opinion is very important to validate our output. Next problem is arrhythmia. A 34-layer CNN is also applied for detecting arrhythmia. So when you're going to increase more number of layers, the accuracy is improved. That's why we are increasing the number of layers. And there are few virtual assistants available. You would have come across this chatbots, Google Assistant. Even in our phones, in our Android phones, we do have the chatbots. Sometimes we can talk, we can chat with them. Alexa, Bixby, Cortana, Siri, these are all the virtual assistants where deep learning is helpful. Next, one important app is Hello. You can just come up with this particular app, which is purely based on artificial intelligence. You can define or determine your skin type based on the questionnaire conducted by this particular app. So start the skin quiz, and finally the product would be suggested. This is one leading app right now which applies artificial intelligence and deep learning techniques. This is how the bot will be discussing with. I have tried this only before I share something in my PPT. I definitely try to verify the data and only then I present. So I started chatting with that particular bot and write skincare products based on a skin texture. The products would be suggested, and you can move on with purchasing of that product. So coming to the last part of the session, I was just talking about the applications. I'll just give an overview about deep learning. Maybe in yesterday's lecture, you would have been familiar with deep learning. Just I wanted to give an overview about the structure of deep learning. What is the importance of deep learning? First one is easy access to massive sets of labeled data. Easy access. Next one is increased computing power. Third one is already we have pre-trained models, and we can utilize those pre-trained models for a problem statement. With AlexNet, I was repeating again and again about AlexNet. It can recognize 1,000 different objects because they have trained it to identify 1,000 different objects, and we can perform a transfer learning. With the smaller data set, we can just modify a few layers and successfully complete our project. So the general process, or what is actually happening, convolution is actually coming from the neural network. We are receiving the input, applying the weight. The product of input and weight is actually, here it is known as convolution. We are going to apply a filter to the input image, and the filter would be acting as the weight matrix. I'll show you the I have the separate layers for the deep learning networks, and a few learning techniques right now which is utilized in all projects: multi-layer perceptron, autoencoders, convolution autoencoders, CNN, recurrent neural networks, LSTM, long short term memory, then MCNN, multi-scale CNN, multi-instant learning CNN. I haven't worked with this, but I have come across all these. But right now, I'm working with CNN. I've completed CNN, fully convolution neural networks also we have applied. So the most different type of architecture of, if you concentrate on CNN, you can go for AlexNet, LeanNet, Faster RCNN, GoogleNet, ResNet, BGGNet, ZFNet. So we do have convolution layer, pooling layer, and lastly we do have fully connected layer where the outputs would be declared. So let me start up with developing a convolution layer. A 2D convolution layer, when you're going to work with CNN, what you have to start with? First of all, the first and foremost, you have to concentrate on the filter, because you have to relate the filter with the weight matrix. Like you have to assign weight for each and every input, right? So first target the filter. So application of filter with the help of striding. Striding is going to be a technique which is going to help in finding out the product of input and the weight. Then feature maps. The most important features would be clubbed up or summed up as feature maps. Then coming to zero padding. What is zero padding? Maybe at the edges, when we are performing some process, there is a possibility of losing information. if you want to save the information, minute information, there is a technique known as zero padding around the image, on all the edges, zero would be included. So if there is any losing of information, the zeros would be omitted. Then batch normalizing of data, that is for batch normalization. ReLU layer is related to the activation function, what we were discussing, right? So ReLU layer is the rectified linear unit. If you get some negative input, that would be rounded off to 0. That is what rectified linear unit does. Then max and average pooling layers. Like this pooling layers is actually for dimension reduction. Collecting the most important information or features from the input image. Then unnecessary information can be dropped out. Finally, fully connected layer will give you the output. Labeling will happen in the fully connected layer. There are two types. One is softmax layer, the other one is classification layer. If you have multi-class problems, then you can go on with regression layer. So this is the most important layers which is available under convolution neural network. If you know very well about this, you can easily develop a network. So as I told you, first the input image is received, and we do have the filter. So this filter matrix would be acting as a weight matrix, and it is going to be convolved with the input image. That is, it would be moved from column wise and row wise, and the multiplication you can just check out. If you consider this particular section 1 1 1 1 1 0 1 0 0, what about the filter matrix 1 0 1 0 1 0 1 0 1? It's going to be sum of product of input and the weight matrix. Finally we get, see, 1 into 1 plus 1 into 0 plus 1 into 1 plus 1 into 0 plus 1 into 1 0 into 0 plus 1 into 1 0 into 0 plus 0 into 1. If you sum up, you get 4. So this is actually the convolved feature. 4 is actually equivalent to this convolved feature. That is how it can be convolved. This is the first process in a convolution neural network. Then you can apply different types of filters or different types of kernels. Why are we doing this? Depending upon your application. Either you want to sharpen it, or you want to blur it, or you want to normalize it, or you want to approximate it. Accordingly, you can change the kernels. So coming to filter and stride, when you're applying the filter, what about striding? So you can see the animation, how the striding is happening. So whatever is available here in the bottom, that is going to be the input image, and this is going to be the filter. How it is convolved, how it is multiplied. So this movement, you can see it is going to be column wise. First it is moving to every column, then it is coming to row wise, right? So stride is 1. So if you are going to set the stride to be 1, it will consider skipping 1 column wise. Like for every iteration, 1 column. Suppose you change the stride to 2, it will be skipping off to the 3rd column. The stride would be twice. That is how you are going to use stride for this particular convolving process. And as I told you, feature maps, zero padding. This is the pictorial representation. If it is going to be a colored image, we do have 3 channels, red, green, and blue. For individual channels, we need to apply the zero padding. Around the input image, you can just check out. We have included 0. Values zeros have been padded onto the input image to reduce the losing of information. So here also the filter is scanning through the input. The padding size of 1. You have to define the size of the pad. In the previous diagram, this is padding size is 2. If size is 2, then you have to include 2 layers around the image. 2 zeros. Animation will represent this. So each and every information is not messed up. It is like including all the possible information. Then this is about batch normalization. Then as I told you, ReLU layer, if you get any negative value, it would be rounded off to 0. That is why this rectified linear function is applied. It is coming under transfer function. So now you can easily relate with the neural networks, what we were discussing, that can be related with the deep learning. Then it will be very easy for us to come up with a solution. And coming to pooling layers, I'll just show you the maximum pooling layer. If I consider this 2x2 filters with a stride 2, if I consider that, what is the maximum value? 1, 1, 5, 6. If you consider what is the maximum value in this 6, then stride is 2. So you have to skip 1, 2 and move on to the third column. Third column, when I moved 2, 4, 7, 8, which is the maximum one? 8 is going to be the maximum one. Next 3, 2, 1, 2, which is the maximum one? 3. So just consider 3. The output would be 3. 1, 0, 3, 4, 4. So now we have applied maximum pooling layer and we have got the most important predominant feature of that particular image. This is the usage of pooling layers. Similarly, this compared to average pooling and summing pooling, what is average? You need to consider the average of the information. 1 plus 1 plus 6 plus 5 divided by 4. That is how average is considered. Summing pooling will be 1 plus 1 plus 5 plus 6, and it would be consolidated and you get the answer. Then dropout layer, I discussed about dropout layer. Next, fully connected layer is the last layer, which is going to classify all the information. This is going to be, all the information would be collected as a feature vector. And each feature vector would be labeled with one particular class and you get the final output. Feature matrix is converted as a vector. That is the, just you understand, like we have only a vector here. And after receiving this, we are moving on to classification. You can apply either softmax or sigmoidal function. And we have multi output, cat, dog, car, truck, anything can be classified. Output layers, softmax and classification layer, we have these types. And with this, the theory part is over. I just wanted to show in our MATLAB, I found this deep learning training box. No need to design, but instead everything is available. Just you need to drag and drop and you can construct your deep learning network. So we do have image input layer, then decide whether you need a 2D layer or 3D layer, transposed convolution 2D layer, transpose convolution 3D layer. Just pick up and drop, and here you can give the filter size, number of filters. Strides can be given here. That's why I was talking about strides. You just give the value of strides here. Then padding, like padding. And what about weight, bias if you want to include? What about learning factor? I spoke about alpha, right? So alpha, learning factor can be included here. So all the informations can be given here and you can execute the networks. So this is for your information. The input layers with the description. Don't want to take much time on this. The explanation and the purpose of all these layer I have given consolidated. Sequence layer, LSTM layer is also available. Time steps in time series and sequence data. If your project is related or depending upon time series, go ahead with the LSTM. Or you can go ahead with the bidirectional LSTM. Even that is available in our MATLAB toolbox. Right. Coming to activation layer, there are many ReLU layers available. Normalization, dropout. If you want to crop the input, again you have a crop 2D layer, 3D layer. Then pooling layer is also available. Average pooling, global average pooling, max pooling. Classification layers, softmax, regression. So everything is available. Just we need to drag and drop, feed in the information, feed in the input image, and we can come up with the output classification problem. So what about the constraints of deep learning? We need massive amount of training data set. That is the only challenge we are facing with deep learning. Also, the accuracy depends upon the quality and size of the data set. That is the one major constraint in deep learning techniques. So all these time, I was discussing about neural network applications and finally ended up with the deep learning information. Hope this session was somewhat, at least some 20 to 30% it was useful. I tried to give my level best. I shared my knowledge and information like these are the areas I'm working right now. And in future also there is a lot of scope in this particular area, that too specifically in healthcare. So most of my projects are related to self-driving cars and related to healthcare. These are the two major areas I'm working with. Anyway, thanks a lot for your participation and patience to be with me to share my knowledge with you. Thank you so much. And now I hand over the session to the coordinators. Thank you so much.
Thank you, ma'am. And participants, do you have any queries?
Participants, any queries? You can post your queries in your chat box. Shubha ma'am. Ma'am, one doubt.
Yes, ma'am.
See, if we select one application, for example, any image processing or signal processing, how can we decide which algorithm or which architecture is suitable for that application? How can we decide?
Yes, ma'am. This has to be thoroughly analyzed with the algorithms. Definitely, you cannot randomly choose any algorithm. For example, if it is memory based, it has to, if it is depending upon time series. For example, EEG signal patterns and ECG signal, it depends upon time series, right? So in that case, you have to specifically choose time series dependent or memory based neural networks.
Okay.
So LSTM would be good for that. I cannot apply every algorithm for all the problem statements. So definitely we need to do a homework on all the algorithms, which would be most relevant to our time. The thing is, many researchers, what they are doing, randomly they are applying, but finally, if you see, the accuracy would be poor. So again, they have to restart the research and they are wasting time. So first of all, before starting the research, it's better to do a thorough literature survey on the networks alone. So based on that, you can decide the network now.
Okay, thank you, ma'am.
Images, generally we apply CNN. CNN is apt for medical imaging. Without any thought, you can directly go for convolution neural networks for all types of images, whether it is MRI or X-ray or pathological image, you can directly go with the CNN. But coming to natural language processing, signal patterns, there you need to find out. There you have different types, autoencoders, CNN autoencoders, LSTM. These are the networks which will support signal processing.
Okay, ma'am. Okay, ma'am. Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am.
Shubha, ma'am, you carry
Yes,
on.
ma'am. Yes, ma'am. Thank you, ma'am. It's my privilege to propose a vote of thank on this seminar. On the behalf of management, the Department of BME, I would like to thank our chief guest, Dr. M. Monica Subhashini, Associate Professor, School of Electrical Engineering, VIT Vellore, who honored this function with her valuable thoughts on the topic Deep Learning Techniques on Medical Imaging. I hope the session was very useful for the participants who are doing the research work in deep learning. Thank you very much, madam. This was really a very informative session. Thank you, ma'am.
Thank you for the opportunity given. I would like to thank HOD Biomedical Department. Also, I would like to thank Sudha ma'am. She was like in touch with me for all the needs. And I wanted to thank PSNA College for giving me this opportunity to interact with the participants and to share my knowledge. Thank you so much, ma'am.
Thank you, ma'am. Thank you, ma'am.
And participants, your next session will start at, and kindly fill the feedback form which is posted in the Zoom meeting as well as in your WhatsApp group.